Hello and welcome to everyone that's watching this video. I hope this video is going to be useful. We're going to cover everything we need to know about exponents, what they are, how to manipulate them in various kinds of forms. Now, of course, we have to start with the definition of the exponent, and please, this is my interpretation, this is my version, my explanation, and this may vary between schools, between teachers, so this is my way of explaining everything about exponents. So, hopefully we know what is a very simple problem, which is 2 times 2. Yeah, 2 times 2 is simply 4. And it would be very tedious, very difficult to write down numbers, let's say if we would have 20 of these. Yeah, so instead of writing 20 times 2 times 2 times 2 times 2 all the way until we have 20 of these, mathematicians made the system of powers. So, for example, we would have 2 to the power of 20, which would mean, well, essentially 2 times 2 times 2 all the way 20 times. So let's give another example. Let's say that we have a 4 to the power of 3. So the base is right here, so this is number 4, and the power is in green, which is right here. So this is the exponent, or also known as the power. And this is, we can call it the base number. So what would this equate to? Now, let's go with 4 to the power of 3, which means that we get 4 times 4 times 4. I like to break it down into 2 problems. So firstly, we solve 4 times 4, which is 16, and then we multiply it by 4, which is 64. Yeah, so the result is 64. So that's the idea of the using exponents. Let's do quickly one more. Let's say we have a very popular number, 2 to the power of 6. So again, the base number is 2, and we're multiplying it by itself 6 times. So equals 2 times 2 times 2. I think you get the idea. 2 times 2 times 2. And let's say I'm not able, there are multiple ways of doing this, but the easiest way, at least for me, I like to do this. This is 8 multiplied by 8, but again, please listen that this is my way of solving these problems. So, these are exponents. Now, there are important rules of how to manipulate exponents. So, let's start with the negative exponent. The negative exponent, it simply means that it's negative. So let's just, firstly, let's make a simple rule that if we have a number, let's say a is a number, and the exponent will be minus b. So these are just numbers. The definition of this is that we can rewrite this number as 1 over the number a with the power of b. So the exponent becomes positive. Now this is very important to understand, is that in the first rule of the negative exponent is that when we put it in the denominator, so below the fraction, it changes into a positive number. So again, I'll put a nice, let's go with an orange arrow, that we see that this minus sign no longer exists. So no longer exists. Let's work out a couple of problems. Very simple. Let's go with let's go with number 1. Let's say, you know what? I don't like numbering problems because we're just practicing. Let's go with 2 to the power of minus 3. So again, by definition, 2 is the blue number here, the blue number, and the yellow number, the power, is 3. Now we have a minus sign, which is a negative exponent, which means that I can rewrite it as the following. So this is our blue number. This is 2. And then we put b, which is a 3. Again, notice that the minus sign is not there. And equals divided by 8. 2 to the power of 3 is 8. Honestly, this is already a correct answer. If we would really like to, and really want to put it in a decimal format, it is possible, but fractions are far more useful and simple to work with. Let's go with one more. Let's go with a really big number. Let's go 6 to the power of minus 3. Okay? We have 6 to the power of minus 3, which I'll rewrite as a 1 over 6 to the power of 3. Again, our power is 3 as such, and it equates to, well, this is slightly difficult. There are tricks how to find this number. But let's just, for the sake of the video, simply go 6 times 6 times 6. It is a relatively big number, so let's start with the one that I know, which is 36. And there's a very nice trick on how to multiply, let's say, bigger numbers, and just simply in a fast way. The fast way is that realize that 36 is simply 30 plus 6, and this is much easier to multiply. So the result is that 6 times 30, right? 6 times 30 is 100. Let me take a purple. 6 times 30 is 180, and then 6 times 6 is 36. There are multiple ways of doing this. This is just one of the, let's say, quicker or simpler ways of doing this. And the result is 1 over 216. And this is our final result. If you have a calculator, you can definitely put it into some decimals, but this is the accurate answer. So, moving on from the topic of negative exponents, which I'll put in a nice box. I'll move down. Going through some fractions. So, let's say the rule we have right here, a very nice fraction. I'll use an abstract fraction, which means that I'll use only letters. So we have A, and the letters don't matter, okay? We have A divided by C, and I'm putting the letters at random. And let's say that we have the exponent C. Let's firstly go with the positive one, okay? Let's go with the positive one. So we can call this, I'm not sure if it's called the rule of fractions, but this is simply another rule. So if let me just, I'm not really sure what's the official name. Let's just call this rule 1. Rule 1 of the video. It definitely has a proper name. Let's just simply call this rule 1. Let's go to rule 2. Rule number 2, and I'm not sure if we're going to cover all of the rules, but the most important rules. The property is that when we put a power or exponent over a fraction, is that we power both numbers. So the exponent kind of travels to both places. So if I want to remove the bracket, I have to put the power here and also here. So we're removing the bracket. Removing, and I'm sure there's a more technical term, removing the bracket. So, what's the result? It's A to the power of C and B, which I chose the wrong color, B to the power of C. And that's essentially the rule. This is the entire rule that the exponent simply, let's call it, travels to both of the numbers. A very, very quick, only one example is that let's say we have the problem 2 over 7 with the power, I don't want to go big, let's go to the power of 2, and the rule states that if we want to remove the bracket, the number 2, the power number 2, which is right here in red, so this is 2, this is 2, this is 2, goes to both numbers. We power both numbers. And let's say I want to simplify this, so this is 4, and this is 7 times 7 should be 49. Hopefully I'm right. I'm not using a calculator, and this would be the result. Rule number 3. Rule number 3 is a very important rule. Rule number 3 is a super duper important rule, is that it's the same thing. It's an identical thing. I'm going to try to use the same colors, which I failed. So let me erase it. Where's the blue? Here's the blue. And I go with a negative c. It's a negative exponent of a fraction. Okay? Good. The trick is that when we have a minus sign and it's a fraction, we can remove the exponent, one way of explaining it, by exchanging the places of the numbers. So A travels, and let's pick up purple. A travels to the denominator, and B travels to the top side. Yeah, denominator and the top. I apologize, I forgot how it's called. Let me quickly just check what's the proper name. Denominator and numerator. Okay. There we go, the numerator. They simply exchange. When they exchange places, we can remove the negative sign of the exponent. So B goes up, A goes down. The minus sign is gone, and we're left with C. Okay, so this is rule number 3. Only applicable when we have a negative exponent. Only applicable when we have a negative exponent with a fraction. Exponent, pen just slid there, of a fraction. Let's see how that works out. So let's say we have a couple of examples. So let's say we have the problem 3 divided by 7 to the power of minus 2. Okay? So the first step I really recommend is flipping the numbers. Or rotating or inversing the fraction is simply switching these two in place, which it becomes 7 over 3. Now, however, do not forget for the number 2, we cannot forget that we have a square of 2. And then we apply the second rule to find the final fraction, which is 7 squared and 3 squared. 49 divided by 9, and I think you cannot simplify it further. Okay, I ran out of space, so I think I'll travel. Oh, whoa, something happened there. I think I'll travel all the way up. Okay, so there's the one last trick that is, or let's say we can call it a rule. So let's go with rule number 4. of exponents is essentially that when we would have a 1 over a, 1 over a with a negative exponent, let's make it very universal with a minus c. Now, this is a kind of a double negative exponent, or let's say 2 times negative exponent. Why is it 2 times? Well, we know as a fact from the first rule. The first rule was that a minus b is the same as 1 over a. This was the first rule. And I'm going to apply the first rule to our specific problem right here. And the trick is that I can rewrite this using the negative exponent. Now, carefully watch what happens. Is that we have a. I'm simply rewriting my number, which is all of this. All of this is my number, so I'm only rewriting this number with minus c right here. Now the trick is that it has an additional negative exponent because we moved it from the denominator to the numerator. So what happens is that this guy has an additional minus. Now hopefully everybody understands at this point that if you have minus and minus, now of course it's multiplied, it becomes plus. So what's the actual rule is that when you have it on the bottom, the result is simply the number with the exponent right here. And for a very tiny demonstration, so let's say that in terms of fractions, let's go with 2 multiplied by 1 over 5. Let's go to the power of minus 2. Let's go minus 1 over 3 to the power of minus 3. I'm just now making a final problem that combines all of our learned lessons at this video. And let's go with 4 to the power of, let's go with minus, actually I'm just going to go with the power of 2. And finally, let's go with the, let's go with 1 over 4 and minus 3. So when you get a big problem, something like this, and I see that I don't have enough space, so I'll try to fit it. You try to break it down. So we're going to solve this problem by solving this block first, and it's going to be like a bubble chart. So this block first. Firstly, I see that I have this outside component. I see that I have a bracket, so I need to remove the bracket. Therefore, I'm going to use one of the rules. So this is equivalent to 1 to the power of minus 2 and 5 to the power of minus 2. 1 with any power is 1. And 5 to the power of minus 2 is exactly the rule that I just described right here. So the result is 25 because we applied the rule. Let's go on with the red block. The red block again has the, let's call it a double negative exponent, or a 1 over a number with a negative exponent. And that's why the result is very simple. This is equals to 3 to the power of 3, which is 27. This is a ordinary exponent right here. And be very careful. I'm going back. I made a mistake. I forgot about this blue guy. Times 2. So the result, in fact, is 50. And the final 4 to the power of 2, I mean, that's very simple. It's just 4 times 4, which is 16. And the very last one, honestly, I think I'm going to put a plus sign. I'm going to change it to a plus sign, and I'm going to finish it off with a nice pink. Okay. So 1 to the power of 3, 4 to the power of 3, and we already learned that this is 1 over 64. Let's combine all of the numbers so that we have the final result. So we have, I'll use the same color. In 50, we have 20 minus 27, very careful, minus 27. We have a plus 16. We have a plus 16. And then we have a minus, very scary number, 1 over 64. Now I'm not going to simplify this. It is possible to put this as at least I'll simplify these three numbers right here. So these three numbers, when we put together, the difference right here. So how to do it in a fast way? This is a difference of minus 11. 50 minus 11 is 39. 39 over 1 over 64. I am not going to simplify it further. This would be the result, just as an example of how to work with exponents.